Hi there, and welcome back to Triplicate and what is part 9 of our attempt to design and build a radically new synthesizer. And the big news is that finally I have come up with a name. Yes, as of now we are working on the Heresy. And here we have the Cambridge Dictionary's definition of heresy: the act of having an opinion or belief that is opposite or against what is the official or popular opinion. And I think that'll do us. That's, I think, where we are trying to go with this. So, having got a name, we need some kind of logo, and because of its heresy, the sort of religious connotations, I have gone for a oldie gothic-y font called Old English 5 from Font Space, if you're interested in these things. And that is very similar to, again, Canterbury, which seems to be the sort of standard gothic-y font. It's just a bit heavier. So I went with that. And around that I have designed a logo. There we go, and I'm not about to spend a ton of time designing a logo because I'm no graphic designer, so it still won't be particularly brilliant once I've designed it. So, there we have it. We have a name and a logo, so we can get on with our designing. Happier for it. So, having got a vaguely religious name for it and a gothic-y font, I am now resisting the urge to do lots of echoey stuff and Halloween-y type effects, since it's actually 2 weeks after Halloween. But we will at this point remind ourselves of why it's called the Heresy, because it has no conventional black and white keyboard, it has no MIDI, it does not have a conventional synthesizer, oscillator, envelope filter architecture, and we are aiming to put a little bit of attitude into its design. So, that excitement over, shall we press on? Okay, so the first thing we're going to do now is stick a logo on. Well, that was upside down, wasn't it? That's on sticky back here. So where do we reckon? Here, maybe here, here I think. Oh. Excellent. So, where are we with this little rig? Okay, here we have the PC end of our little test setup we were using to get the strings and the turntable working. So if we hit run, oh, there we go. And that is working nicely, but it is only outputting 1 number a second, which is way too slow for what we want. We want it to output, I suppose, as fast as possible. So we'll have to go back into the datasheet and see how fast it'll output. And if we What is the matter with that dog? If we go into the STM32 end and put that into string mode, we should get some string output. Right, go. Let's go back into our PC. Oh, there we go, and we should get some string output. Of sorts. Okay, so here we are looking at the AS5600 datasheet, the little chip that does the angle measurement. And the way this thing works, it's got Hall effect sensors pointing at right angles to each other, and it gets values off all these and digitizes them, an analog digital converter, and then does a calculation from the result to get to an angle. So since it has an analog digital converter, it has some kind of sampling rate, which is how often it samples, which is, it says here, 150 microsecond, which is 6.67 kilohertz. So ideally we would like to take a reading out of it every time it takes a reading, but there is no way I can see that it'll tell you when we've got a reading. You see, it's an I2C interface, which is a slave interface at the chip, so it gives you its latest reading when you ask, but it has no way of telling you when it has a new reading. So I think what we have to do is we just have to take readings at a rate that suits us, and well, for now we'll just have to see what happens. Okay, so I have created a new version of the code, which will be the final run version of the code eventually. Well, it's the run version of the code, and here's what it does. So I start by stopping the DMA for the analog to digital and reading the values from the I2C from the rotation sensor, and then I output the data to the PC. So this is 8 words. The first word is the rotation sensor, then there are 6 string values, the tops of the string and the actual where your finger is on the string, and then A596 is just a number to tell the PC the end of the message, so they can synchronize. And all these numbers here are only up to 0 FFF, so that number will never actually occur as a value. So it sends these values out to the PC, puts the pin high again, and then finally it sets the DMA going for a new A to D and puts the pin low again. So that tells me how long these various things take. So shall we fire it up? Yeah, so it's all uploaded, so we just press go and off it goes. And this is the PC program, which I will start. Run. There we go, and you can see I've put 7 values there at the top, which are the 6 from the strings, and the first one is the rotation sensor. And you're going to have to take my word for it because I'm turning the other camera on, but there you can see the angle goes up to FFFF and back down to 0, so that's working. But how fast is it working? It's the other thing we want to know. So here is the trusty picoscope. So the first test line up is the start of the reading the I2C, the rotation sensor. Then it outputs the serial, and that last bit is it starting the A to D again. Excuse the slightly erratic triggering. And you can see, so that's 0. So if we look at that point, it's 2.6 milliseconds, and we were looking at 1 millisecond, but that might do. So we are going to now set the thing to 3 millisecond update and see how that goes. And if it's not fast enough, we can probably read the I2C quicker. We can use a higher baud rate for the serial, and we can use the interrupts or the DMA for the serial, so we can be outputting the last serial values while it's reading the new rotation values. And it probably reads too much from the rotation sensor. Anyway, we know we can speed it up if we have to, but probably not more than to 2 millisecond update. However, for now we're going to see what we've got, see how it performs, and if it's not performing fast enough, then we're going to have to speed it up. Okay, so now I have made it update at 3 milliseconds, and I've taken some of the update out off that test pin, so it just goes up at the start of getting a set of values and down at the end. And that is uploaded and ready to rock. So should we press go and see what happens on the scope? So yeah, that looks alright on there. So what's going to happen on the okay, that looks like it's working. So I think we need to have a look at what is coming out of our rotation sensor and our strings. So I will have a think about how the best we look at that and assess it, and I will bring you back. So let's have a look at the PC program and see what we are getting out. Run. Here we are. So yes, there are numbers coming out, but as you can see, it's quite jerky. They should be spraying numbers out continuously, well, once every 3 milliseconds, though the display won't update. By the way, sorry about the cold, I'm a bit croaky today. So we need to have a look into why that is happening, and to do that I've got it printing out stuff into a text file as it goes along, because printing out onto this memo seems to be quite slow. So let's have a look, see what appears in that text file. So here's a text file, and you can see this is ticks, is the it's a Windows timer message essentially, which is being repeated as fast as possible. I'm putting the timer, and these are milliseconds, so it's actually coming out at 20 odd, 20, even more sometimes, milliseconds.
and the bytes read is the total bytes read, and the buffer is the write point in the buffer, and we should be getting maybe 3, 4, 5 messages every tick, and we don't until we get a whole pile of messages. And this end number here, I've just temporarily changed that so it's actually a counter, so I can just check all the messages are arriving, because that should just count up, and then we get a whole pile of messages, and then we're back to waiting for 600 to 860, 250 odd milliseconds, does nothing, then we get a whole pile more messages out, and then a load more, etc., which is no good. So after a bit of digging about, I discovered if we go in the device manager and into the COM port, it'll put it up on the other screen, port settings, advanced, come on, there is a latency time in milliseconds. Don't know why there is, who would want your data 16 milliseconds late, but if we set that to 1, okay, and I did have a look around, and there is no easy way of setting that in code, so we've got to set it up like that. Hopefully it'll remember the setting. Now if we run it, come on, there we go. You can see it's, well, the display's updating as fast as it'll update, and our literacy counter is counting up so far as we can see there. So if we go into the text file, yes, that's where we're getting a bunch of messages for every tick. And the little counter number is counting up, so I think we are good at that. So we can now try and do something with our data. Okay, apologies again for the somewhat croaky voice, I'm still full of cold. So let's have a look at our rotation center and see what kind of signals are coming out of that. So I have a function here called do rotation, which takes the raw input, which is 0 to FFF, and it again, we work in floating point because it's always easier, but this sine business is using the most significant 2 bits, and the most significant 2 bits of the last value to detect when it's gone round from FFF to 0 or 0 to FFF, because we find out we don't have a number system that works properly for circular numbers, for circular values. So instead what it does, maximum rotation angle, the maximum is about 4 or 5 rotations, 4 I think. So that calculates that, and the speed, it just takes the last angle and the current angle and takes the difference between the last angle and the current angle, which is pretty crude, but we'll see how it goes. Okay, so let's fire this up. So that's going nicely, so we will go backwards 3, forward 6, give it a bit of backwards and forwards and see what that comes up with. So if we load this into here. We can see that was our backwards 3, our forwards 3, and there's our wobble about, and we can see that the velocity measurement, the speed measurement, is a bit noisy. So we need to address that, I think. Let's put the frequency analysis here. Yeah, that's the purple trace relative to the green trace, which is the position. So we will leave that for now, since it's actually doing something, and go on and look at see what's coming out of the strings and how good that is. Okay, so I have just done a little bit of coding to organise the data from the strings and normalise it, and just put it out to the audio file. So, and the top and the value of string 1, the top one, are going to the audio file. So let us see how that performs. So we will just go from the bottom to the top and back to the bottom, and then we will do that to see how the top value is shaping up. Okay, so let's have a look at that. Okay, and whoops, we can see that we have a problem with noise. So that was to the bottom, no it isn't, back to the top, and that was me holding 2 points on the string to short a lot of it out, so that, to test the top value, and oops, it's a bit noisy. So let us look just here, we'll look at that one. Yep, so that is what the value is supposed to be, and we can see it's sort of dropping out. And I think that is because this copper strip is mucky. So I'm sure you can see well enough that there's stains, and it's very tarnished. This is just thin copper strip which I've screwed down to the wooden base, and lumps in it because I think it was supplied sort of semi-rolled up, semi-squashed up. Anyway, shall we endeavour to clean this? So I've got some kitchen towel, I've got some IPA, and I've got some pan scrubber. So let's see what happens. Let's just blather a load on. Let's see if we can hook the string off there. But, get this looking. Right. Copper again. Very quickly. Wipe that off. Black on there. Right, so I am going to continue with that, do the other 2 strings, and maybe have another go at this as well. And you don't want to watch me scrubbing at this, so I'll bring you back. Well, there she is, some moderately shiny copper. Doesn't come up brilliantly, even with some serious elbow grease. Anyway, let's see how that performs. So, run. It's all working. Yeah, this little temporary text string here is a display of the 3 strings and their tops in order rather than random order that the others are. Right, okay, shall we? Try that. Okay, let's see how that has performed for noise and dropout. Nope, still loads of dropout. So that is a problem. We are going to have to look into. And probably we're going to have to come up with some kind of a software fix, because I do not think I am going to get it any cleaner. I will look at the connections on the things. But that, I think, is for next time. Okay, well, I'm going to leave it here for this video. I haven't gone on as far as I'd hoped, but I've had this horrendous cold all week. And I have other things I need to be getting on with. So next time we will sort of start to integrate the ASIO ASIO into our master program. And we will, I guess, start to look into some of the problems we've identified, if not solved, with the inputs from our player interface. So until then, well, until the next one, which will be on a different subject, it's goodbye from Triplicate.
Goodbye.